Okay, so in this new unit we're going to start talking about still derivatives, but now we're going to start focusing on derivatives and when they equal zero. So first thing we're going to look at is a theorem called Rolle's theorem that tells us if that we have a function, a continuous function, on a closed interval from a to b, and it's differentiable from a to b, then if f of a equals f of b, so my two x values a and b have a common y value, then there has to be at least one number in that interval, at least one number, call it c, in between a and b, where the derivative is zero. So there's three specific cases that could make that happen. One, where when I plug c in, I get it gives me a larger y value than a. So suppose I have some c in between a and b. So what if f of c, so the y value of c, is greater than the y value of a? Well, remember, according to this theorem, f of a is equal to f of b, so b has to be at that same y value as a. So notice that in order to make this continuous and differentiable, I have to connect this with a smooth line. And so notice that my derivative would be 0 right here, because as we talked about before, when I'm flat, I have a derivative of 0. So we looked at that when we talked about graphing derivatives in our prior unit. If I look at my second case, what if c, again, c is just some value in between a and b, what if c is less than a? So the y value that is associated with c is less than the y value that's associated with a, and as I pointed out before, f of a and f of b are the same. Well, again, notice that I kind of missed that point a little bit. I'm still missing it. Notice again that here I have, again, a y value, or excuse me, a derivative of 0, because again, I'm flat. Then the third situation, what if f of c is just some constant in a and b? So say I have a line that looks like this, pretend that's a straight constant line. So at least one point, remember, has to have a derivative of 0. Well, as we've looked at before, a straight line or a constant function has a derivative of 0 everywhere for all x values. So we're going to just look at a couple examples. I think I have two, where we'll determine if Rolle's theorem can be applied, and then if it can be applied, we'll find the value where my derivative is 0. So if I look at my first function, if I have f of x equals x to the fourth minus 2x squared, and I'm in the interval from -2 to 2, in order for Rolle's function to be applied, I have to make sure that -2 and 2 give me the same y value. So I'm going to plug -2 in, maybe. Plug -2 in, so I'll have -2 to the fourth minus 2 times -2 squared. So that gives me 16 minus 2 times 4, which gives me 8. If I also plug in my other endpoint, 2, I get 2 to the fourth minus 2 times 2 squared. Well, again, that gives me 16 minus 2 times 4, which again gives me 8. So since Rolle's theorem can be applied, I know that my derivative has to be equal to 0 somewhere inside that interval. So I'm going to find my derivative, so I can go ahead and just use that power rule and get 4x cubed minus 4x. I remember Rolle's theorem tells me I can find where my derivative is 0, so I'll set my derivative equal to 0. And in order to solve this, I can factor out a GCF of 4x, leaving me with x squared minus 1. Setting each piece equal to 0, I get x equals 0, or x equals plus or minus 1. Don't forget when you take the square root that you need both the positive and the negative. So there are my two values where my derivative is 0. On example 2, it says find the x-intercepts of f and show that f prime of 0 occurs at some point between the two intercepts. Find this point. So first thing it tells me to do is find my x-intercepts. Well, I know that in order to find my x-intercepts, I plug 0 in for y. I see that this is a quadratic equation, and I can factor it to be x minus 2 times x minus 1. Therefore, my x-intercepts occur at x equals 2 and x equals 1. So my x-intercepts are 2, 0 and 1, 0. Well, according to Rolle's theorem, because my y values are the same on the interval between the interval from 2 to 1, I know that my derivative is going to be 0 somewhere between 2 and 1. So I'm going to go ahead and find that point where my derivative is 0 in between 2 and 1 by first finding my derivative of my given function. Again, I just use the power rule, pretty basic. I set my derivative equal to 0. Pretty easy to solve. I just add 3, then divide by 2. is going to be the x value that makes me have a derivative of 0. And I check, and 3 over 2 is between 2 and 1, or is between 1 and 2 is probably the better way to think of that interval. I did not check on the last one, so I'm going to back up a moment here. And just double checking because I didn't do it before. 0 is in my interval, and both plus and minus 1 are in my interval. There will be times when they'll give you an interval and you'll find more than one x value that gives you a derivative of 0. So just make sure you check that the ones that you decide are your final answer are in your given interval. And I believe that is the final example. So that is it for Rolle's theorem. So make sure your endpoints give you the same y value. If you have two endpoints of an interval giving you the same y value, then according to Rolle's theorem, your derivative has to be 0 somewhere in that interval.